Let's begin with the first question. Assertion. Two resistors have value R each. So let us take two resistances having the value R each. Okay. And their equivalent resistance is R by 2. So if we connect it in series, the total resistance is going to be R1 plus R2, which means it is 2R. Okay, total resistance is going to be 2R. No. So then it must be parallel connection. So when two resistors are connected in parallel, this is R1 and this is R2, we will get the formula total resistance is going to be R1 into R2 divided by R1 plus R2. So now we have the same resistance, so therefore R into R divided by R plus R, which is going to be R square divided by 2R, okay, which in turn can be cancelled and we get R by 2. Yes, R by 2, that's right. So when we connect it in parallel, we get R by 2. The reason given is, given resistance is connected in parallel. Yes, it is R by 2. So by connecting it in parallel, we get the resistance R by 2. So assertion is also true, reason is also true, and reason is the correct explanation of assertion. So then the option A will be the correct answer. Okay. In a circuit, if two resistors of 5 ohm and 10 ohm are connected in series, okay, think that we are having two resistances, they are connected in series. Okay, this is R1 and this is R2. What will be the current? So the current flowing in the circuit is going to be the same current will flow through this R1 and R2. So if the current is going to be same, what will be the ratio of the current? If I take I1 divided by I2, the two currents are going to be the same. So I divided by I, it's going to be 1 by 1. So the ratio must be 1:1. The correct option would be option A. When two or more resistances are connected end-to-end connection, okay, so that the same current flows through each one of them in turn, they are said to be. See, when two resistors are connected end to end, this is called end-to-end connection. So in this end-to-end connection, the current is going to be the same. So this connection is called series connection. Option A is the correct answer. When two or more resistances are connected across 2 points so that each of them provides a separate path for the current. So if they are providing separate path for current, then it must be parallel connection. So since we know that, see, this is the connection of 3 resistors in parallel. Okay, here what happens, the total current will be dividing. So here the current I1, here the current I2, and here the current I3. Okay, so current is dividing, that means it's a parallel connection. What is the maximum resistance which can be made using 5 resistors each of 5 ohm? So in order to get maximum resistance, we need to go for series connection. So when we go for series connection, so like this 5 resistance should be connected in series. R1, R2, R3, R4 and R5. So when they are connected in series, we know that if n number of resistors are connected, then in series connection it's going to be n into R. So this is equal to n into, what is the value of each resistor? 1 by 5. So it is 1 by 5. And how many resistors we have? 5. So therefore 5 into 1 by 5. It's going to be 1 ohm. So the answer must be 1 ohm. Option D is the correct answer. Sixth question. What is the minimum resistances which can be made using 5 resistors each of 1 by 5 ohm? So minimum resistance means we need to go for parallel connection like this. Okay, like this we need to connect it 5 resistors should be connected. And for this, the total resistance is given by Rp is equal to R divided by N. So N represents number of resistors. How many resistors we have? 5. So divided by 5. What is the value of the resistance? 1 by 5. So 1 by 5. So the total resistance would be 1 divided by 25. 1 divided by 25 ohm. That's the correct answer. So option B is the correct answer. 7th question. In the above diagram, 3 identical bulbs B1, B2, B3 are connected in parallel with a battery of 4.5. What will happen to the glow of other bulbs if the bulb B3 get fused? See, in this parallel connection, suppose if this B3 is going to get fused, so no current will be flowing here. The current will be 0 in this. Okay, current is going to be 0 here. And from this battery, the current will be flowing this way and this way. Okay, so all other bulbs will be getting the supply. Okay, let us see the option. All other bulbs will get fused as well. No, so they are not getting fused. Other bulbs will glow with same brightness. B1 will get fused, but B2 will glow with same brightness. No. B2 will get fused, B1 will glow with the same brightness. No. So the option must be option B. What's the correct answer? Option B is the correct answer. Other bulbs will glow with same brightness. Okay. Now these two, B1 and B2, doesn't get fused. Okay. So option B is the correct answer. In an electrical circuit, 3 incandescent bulbs A, B, C of rating 40 watt, 60 watt and 100 watt respectively are connected in parallel to a electric source. Okay, how they are connected? They are connected parallel. Which of the following is likely to happen regarding their brightness? See, we have here in this 3 bulbs. Okay, so all these 3 bulbs are connected in parallel like this, and they are connected to the same voltage source, which is having, this is 40 watt, this is 60 watt and this is 100 watt. Okay, 100 watt. So usually 100 watts, the bulb which is having more watt, okay, it's going to glow brighter, more brighter. Okay, so here in this, it is connected in parallel, so voltage is going to be the same. The current will be dividing. Okay, so with that same voltage, I can find the current flowing through each of the bulbs. So which bulb will be glowing more, A, B or C? C will be glowing more, have got more watts, isn't it? So here the brightness of all the bulbs will be same. No. Brightness of bulb A will be maximum. No. Brightness of bulb B will be more than that of A. Bulb B will be more than that of A. Yes, that's right. Brightness of bulb C will be less than that of B. Brightness of bulb C will be less than that of B. No, that's not correct. So the correct option must be option C. 9th question. In the above diagram, 3 identical bulbs B1, B2, B3 are connected in parallel with a battery 4.5 volt if the wattage of each bulb is 1.5. Okay, all are having the same power. How much reading will ammeter A show when all the 3 bulbs glow simultaneously? Okay, so ammeter will show, here we know power is given, power is 1.5 and What else is given? Voltage is given. Voltage is how much? 4.5. So I, we can find current. I is equal to P by V. So with this I can write 1 by 3. Okay, that will be the current flowing in each of the bulb. If the wattage of each bulb is 1.5. See, where is the ammeter being connected? They are asking ammeter A. Ammeter A, see, this is 1 by 3, this is 1 by 3, this is 1 by 3. So when you add all these readings, what we have calculated is, we have found out the current in each bulb. So we found that it is 1 by 3. Okay, here it is 1 by 3, here it is 1 by 3, and here it is 1 by 3. So in the question they have asked, in the ammeter A, that means this ammeter. So that means you should add all these three. So when you take LCM of this, 1 by 3 plus 1 by 3 plus 1 by 3 is 1 amps. So the correct answer will be 1 amps. Option C is the correct answer. From the above diagram, find the effective resistance of two 8 ohm resistor in the combination. So here, these are the two resistances of 8 ohm. We have to find what will be the total resistance of this combination. That means two resistance connected in parallel. The formula will be R1 into R2 divided by R1 plus R2. And it is of same resistance value, so you can take half of that. We have already seen. So 64 divided by 16 is going to be 4 ohm. So the total resistance would be 4 ohm. Okay, option A is the correct answer. From the above diagram, find the current flowing through the 4 ohm resistor. So how to find the current through this 4 ohm resistor? So here we need to find the same current will flow here, isn't it? The same current will be throughout because it is series connection. So how to find it? We need to find the total current. So V is equal to I is equal to V by R. So this will be total resistances. So total resistances of combination. Okay. So these two are connected in parallel. So that will be in series with this resistance. So therefore this we have already found that its total resistance is 4 ohm. And this 4 ohm is connected in series with this. So therefore it becomes 4 plus 4, which is 8 ohm. And the voltage here is 8 volt. So 8 divided by 8, it's going to be 1 amps. So 1 amps is the current flowing through 4 ohm resistor. Option B will be the correct answer. Okay, 1 amps. From the above diagram, find the potential difference across 4 ohm resistor. See, we have found that the current flowing through this is 1 amps. Then what will be the potential difference? We know V is equal to I into R. So I is 1 and R is 4. So 1 into 4, it's going to be 4 volt. So option C is the correct answer. From the above diagram, find power dissipated in 4 ohm resistor. So we know we have to find out the power dissipated. So what is the formula for power dissipation? P is equal to I square R, isn't it? So what is the current flowing? We saw it is 1. And what is the resistance value? 1 square into 4. So it's going to be 4 watt. 4 watt is the correct answer. Option D is the correct answer. From the above diagram, find the difference in the readings of the ammeter A1 and A2. See, whatever the current flowing here, the same current will flow here. So here also I, here also I. What is the difference of this? I minus I is going to be 0. So there should not be any difference in current. So ammeter will be same. Ammeter reading will be same. So no difference at all. Correct. Option A is the correct answer. 3 resistors of 10 ohm, 15 ohm and 20 ohm are connected in series in a circuit. If the potential drop across the 15 ohm resistor is 3 volt, find the current in the circuit. See here, 10 ohm, 15 ohm and 20 ohm, all these are connected in series to a cell or battery of 3 volt. Okay, and we need to find the potential difference across 15 ohm. That means V2. I need to find what is V2. V2 formula is I into R2. So how to find I? I is equal to V by R. So R is going to be RS, total resistance. So 20 plus 10, 30 plus 10, 45. Okay. So 45 and V2 we know it is 3. 3 divided by 45. Okay. So if you find this, you will be finding out the current. And yes, they are asking you to find out the current. Find the current in the circuit. And the potential difference across the 15 ohm is given as 3 volt. Not the total voltage is given, ma. Total voltage is not given as a 3 volt. So this is wrong. See, the potential difference, 3 resistors are there. And here we apply the total. This is the source voltage. Okay. So here across this V2 is given. V2 is 3 volt. V2 is given as 3 volt. So this is 10, this is 15, this is 45. Sorry, it is how much? 20 ohm. Correct. Okay. So we know what is V2. V2 is 3 volt. So 3 is equal to I into 15. R2 is 15. So how you will get I? I is equal to 3 by 15. Okay. So what is 3 by 15? 1 by 5. So what is 1 by 5? 1 by 5 is 0.2. So 0.2 amps is the correct answer. Okay. 3 resistors of 10 ohm, 15 ohm, 20 ohm are connected in series. If the potential drop across the 15 ohm resistor is 3 volt, find the potential drop across the 10 ohm resistor. Okay. So the same problem. So here we have 10 ohm resistor, and here this is 15 ohm and this is 20 ohm. Okay, so here they have given it is 3 volt, and from this we have found that V2 is equal to I into R2. From this we found what is I. Okay, what was I? I is equal to V2 divided by R2, which we found as 0.2 amps. That is 3 divided by 15. Okay, just now we have seen, and we need to find here what is the potential difference across this 10 ohm resistor. That means V1. So how to find V1? V1 is equal to I into R1. Okay, I into R1. So what is I? 1 by 5. And what is R1? 10. So you can cancel this. You get 2 volt. So 2 volt is the correct answer. Option C is the correct answer. A circuit has a line of 5 amps. How many currents of rating 40 watt 200 volt can simultaneously run on this line safely? See, 40 watt is the power given, and this is the voltage, and this is the current. How many lamps? So here is, so like this we need to connect so many lamps here. So we need to find how many lamps we can connect like this. Okay, having the voltage 200 volt. Okay, and the power of the bulb is given, that is 40 watt. Okay, and line current, that means the total current is given. Total current is how much? 5 amps. This is 5 amps. So having known this voltage and this current, V into I. So how we will find out the number of bulbs using this formula. We know V into I is power. Okay, so V into I is power divided by P. So we know N is equal to Vi divided by P. So what is the voltage here? 200. So 200 into I is how much? 5 divided by P is 40. So you cancel this. 4 5s are, so 5 5s are 25. So 25 is the correct answer. 25 lamps of such kind can be connected in parallel. Okay, next. Here in 18th problem, in the above diagram find the current drawn by the battery. So we need to find this current. So how to find this current? These two resistances are in series. These two resistances are in series. So we can write this resistance and this resistance. So here it is 20 ohm and this is also 20 ohm. Okay, so that has been connected to 3 volt battery. Okay, like this. So we need to find out the current. This current we need to find. Current will divide here. So what is the total resistance we need to find? RP. RP will be 20 into 20 divided by 20 plus 20. It's going to be 10 ohm. So we got the total resistance. So we can find the current. Current is equal to V divided by RP. So which is equal to 3 divided by 10. Okay, 3 divided by 10, which is going to be 0.3 amps. That is going to be the current. So option A is the correct answer. 0.3 amps. 10 identical wires, each having resistance 1 ohm, are connected in parallel. What will be the resistance of the combination? See, 10 resistances like this, we have to connect it in parallel, and we need to find what will be the total resistances. So what is that formula? If identical resistances means, I told the formula Rp is equal to R divided by N. Okay, this is equal to 1 divided by how many number of resistances? 10. So it is 0.1 ohm. 0.1 ohm is the correct answer. Option C is the correct answer. In the above image, maximum heat will be produced in which circuit? See here, 12 volt and only one resistor is there. So 12 divided by 2, it's going to be the current. So 6 amps current is flowing here. 6 amps of current is flowing here. In this you can find that it is, this is the current I. So I is equal to 12 divided by 4. So 12 divided by 4, it's going to be 3 amps here. What about here? Here we find here 2 into 2 divided by 2 plus 2. So that's going to be 1 ohm. So 12 divided by 1, that is going to be the current I here. So here we get 12 divided by 1, it's going to be 12 amps. So the current flowing in this third circuit is going to be maximum. Option D is the correct answer. Two resistors of resistance 2 ohm and 4 ohm when connected to a battery will have. See, these two resistances when connected to battery will have same current flowing through them when connected in parallel. No. So same current will not flow when connected in parallel. Current will divide in parallel circuit. So A option is wrong. Same current flowing through them when connected in series. That's right. Same potential difference across them when connected in series. No, in series connection voltage divides. So this is wrong. And option D, different potential difference across them when connected in parallel. No, they have same voltage. So option B is the correct answer. Assertion and reason type question. When resistors are connected end to end consequently, they are said to be series. Correct. In case the total resistance is to be increased, the resistors are to be connected in series. Yes, correct. Both are correct. But this is end to end connection. End to end connection, consequently, they are said to be series connection. Why they are called a series connection, it is not mentioned, but here they have given total resistance is to be increased, means we need to connect it in series. So the reason is not correct explanation of assertion, so it must be option C. No, see, it must be option B, because here reason is false. No, this is not false, this is correct only. So therefore option B will be the correct answer. It is not the correct explanation. Okay, so this is not the correct explanation. Option B is the correct answer. Next, when resistors are connected between the same 2 points, that means they are parallel. If the total resistance is to be decreased, then we have to connect it in parallel. Yes, both are correct. Both are correct, but this is not the correct explanation of assertion. So option B is the correct answer. Next, what happens to the resistance when resistors are connected in parallel? So when we connect it in parallel, total resistance is going to decrease. Option A is the correct answer. What happens when to the resistances when resistors are connected in series? It will get added up. That means it's increasing. Maximum resistance we can get. So option B is the correct answer. In series combination, which remains constant? In series, current remains constant. In parallel combination, which remains constant? Voltage remains constant. Option A is the correct answer. In the above image, two resistor wires A and B have the same cross-sectional area and are of same material, but A is longer than B. Which ammeter A1, A2 will indicate higher reading of the current? So here in this case, you need to know that same cross-sectional area and same material, but A is longer than B. That means this length, this length is going to be longer than this. So this is 2L. So when the resistance, when the length is doubled, okay, so what happens to the resistance? Resistance is increasing. So when the length is increasing, resistance is increasing, what happens to current? Current will decrease. So here where the current is decreasing, in ammeter A1 the current is decreasing. So where will be high? Here in A2 the current reading will be high. So option A is the correct answer. A2 the reading will be more. 3 incandescent bulbs of 100 watt each are connected in series in an electric circuit. In another circuit, another set of 3 bulbs of same wattage are connected in parallel. Which of the following statements are true? Bulb in 2 circuits will glow with same brightness. Bulb in 2 circuits will glow with a different brightness. Bulb in both the circuits will not glow. No, option C cannot be. It will glow. And here will glow with same brightness. No, because series connection and parallel connection, it will be different. In series connection, what happens? Voltage divides. A voltage divides means what happens? The brightness will decrease, whereas in parallel connection brightness will be more. So it will be option B is the correct answer. In the 2 circuits there will be different brightness. Three incandescent bulbs of 100 watt each are connected in series in an electric circuit. In another circuit, another set of three bulbs of same wattage are connected in parallel. Now let one bulb in both the circuits get fused. Which of the following statements are true? See, in series connection, what happens if one bulb get fused, then others will not glow. In parallel circuit, the other bulbs will glow. So in series connection, if one bulb is fused, then the bulbs will not glow. Correct. Option A is correct. In parallel connection, if one bulb is fused, then other two bulbs will glow. Yes, that's also correct. So both A and B are correct. Option C is the correct answer. Next, 5 ohm, 10 ohm and 15 ohm resistors are connected to 30 volt. And in the above image of an electrical circuit, what is the current flowing when the circuit is closed? Here the circuit is closed, and what will be the current flowing? So we know this is what we need to find. So here we need to find the current. So current is equal to V by R. So if they ask you to find what is the current in 5 ohm resistor, you should not take 30 divided by 5. Okay, so current is same. No, you should consider all the three resistances. So therefore it is 30 divided by 5 plus 10 plus 15. So it's going to be 30 divided by 30. So it's going to be 1 amps. Okay, option A is the correct answer. In the above circuit, what is the potential difference across the 15 ohm? Just now we found that 1 amps is the current. If 1 amps is the current flowing here, what will be the voltage V3? V3 will be equal to I into R3. So what is I? I is 1, R3 is 15. So 15 into 1 is 15 volt. Option B is the correct answer. A current of 1 amps flows in a series circuit containing an electric lamp and a conductor of 5 ohm when connected to a 10 volt battery. Find the resistance of the electric lamp. So here we have an electric lamp and the conductor 5 ohm. Okay, this resistance we don't know. It is connected to a 10 volt battery, and the current flowing here is 1 amps in a series circuit, and we need to find what is the resistance of the lamp. So we know that V by I is R. So what is the value of the resistance R here? Total resistance is going to be 5 plus X. So here total resistance, we know that it is X plus 5. Okay, because they are connected in series, and the voltage is 10 volt and the current is 1. So X plus 5 is equal to 10, where X is equal to 10 minus 5, which is 5. So 5 ohm will be the unknown resistance. That means the resistance of the electric lamp. Option B is the correct answer. Two resistors with resistance 5 ohm and 10 ohm respectively are connected to a battery of 6 volt. To obtain maximum current, when we will get a maximum current? We will get maximum current in the parallel connection. Okay, so maximum current in a parallel connection. So that means 5 ohm and 10 ohm, they are connected in parallel to a battery, okay, of 6 volt. Okay, so what is the amount of current flowing in the circuit? I need to find the total current here. So I is equal to V by R. So here we know the two resistors are connected in parallel to get the maximum current. So 5 into 15 divided by 5 plus 15, that will be the total resistance, whereas the voltage is 6. 5 into 15, sorry, 5 into 10, 5 into 10 is 50 divided by 5 plus 10, that is 15. So you can write 6 into 15 divided by 50 is what we get. This is 10s are, this is 3s are. Okay, 18 by 10 is 1.8. 1.8 is the correct answer, option B. Two resistors with resistance 5 ohm and 10 ohm are connected to a 6 volt battery to get the minimum current. What is the amount of current flowing in the circuit? See, minimum current means the two resistors are connected in series. This is 5 ohm and this is 10 ohm. They are connected in series to a battery of 6 volt. So what is this current? I is equal to V by R. V is 6 and R is 15. What is 6 divided by 15? It is 2 by 5. It is 0.4. Okay, option A is the correct answer. In the above image, a circuit is given. What is the value of the current through 6 ohm resistors? We need to find what is the value of the current through 6 ohm resistor. That means I1 current. How to find this I1 current? See, we know that in a parallel circuit, voltage will be the same. So, voltage across AB and voltage across CD, it's going to be the same. So, I can find this current I1 as I1 is equal to V divided by, okay, V divided by 6 plus 3. So, we should add these two resistance because they are connected in series. So, that resistance we need to take. So, it's going to be 4 divided by 9. 4 divided by 9. Okay. So option A is 0.45, option B is 0.40, option C is 0.44 and option D is 0.48. So what is 4 divided by 9? It is 0.44. Option C is the correct answer. Okay. Two resistances when connected in parallel give resultant value of 2 ohm. When connected in series, the value becomes 9. Okay. So what they say is, let us have two resistances. So when two resistances are connected in series, it will have 9 ohm, and when connected in parallel it have 2 ohm. So which it would be? Let us see the option A. 6 into 3 divided by 6 plus 3 is how much? 18 divided by 9, that is 2. Yes, we are getting parallel. And then series connection is 6 plus 3 9. Yes, so option A is the correct answer. See, when we go for the second option, 3 into 3 divided by 3 plus 3, it's going to be 1.5. No, wrong. So option C is 6 into 6 divided by 6 plus 6 is going to be 3. No, it's 2 ohm. So therefore option A is the correct answer. A piece of wire of resistance R is cut in to 5 equal parts, and these parts are then connected in parallel if the equivalent resistance of this combination is R dash, and then what will be the ratio R by R dash. See, a long wire, so this has been cut into 5 parts, and each part is going to become R by 5. Okay, R by 5. So that means when they are connected in parallel, So when all these are connected in parallel, all these like 5 parts has been connected in parallel, we need to find the total resistance. That resistance is going to be R dash. All are having same value, no, which is R by 5. So it's going to be R divided by N. So how many? 5. So R divided by 5 here. So here, what is the R value? R value is R by 5. Each resistance is having R by 5 value. So R divided by 5 divided by 5. It's going to be R by 25. So R divided R dash is equal to R by 25. Then what is R by R dash? See, R dash is equal to R by 25. What is R by R dash? So from this we can write R divided by R dash will be equal to 25. So option B is the correct answer. Here in this circuit, R1 is 10, okay, R2 is 40, R3 is 30, R4 is 20 ohm, and R5 is 60 ohm connected to 12 volt battery. Find the total resistance. We need to find total resistance. That means this is parallel connection, this is parallel connection, then both are connected in series. Okay. So therefore, what is 10 into 40 divided by 10 plus 40? So we need to find the total resistance, right? So therefore, 10 into 40 divided by 10 plus 40. 400 divided by 50. 400 divided by 50, it's going to be 8. So here the total resistance is 8. What about here? Here it's going to be 1 divided by 1 by 30 plus 1 by 20 plus 1 by 60. Okay. So when we take LCM for this, we get here into 2's are. So 2 plus here 3's are. So 2 plus 3 plus 1. Okay. 2 plus 3 plus 1 divided by 60. So when 60 goes up, it is 60 divided by 6. It is 10 ohm. So this is 10 ohm and this is 8 ohm. So total 18 ohm. 18 ohm is the correct answer. Option C is the correct answer. In the above circuit, find the total current. So just now we have found out the total resistance. This is 10 and this is 8 and this is 10, total 18. And total current is going to be I is equal to V by R, where V is 12 and R is 18. So 6 2's are and 6 3's are, 2 by 3 we get. So we get 0.66. 0.66 is going to be 0.666. So which is 0.67. Option D is the correct answer. In the above image circuit of the circuit diagram, a cell ammeter have negligible resistance. The resistance are identical, and when switch K is open, ammeter reaches 0.6 amps. What will be the reading of ammeter when switches K is closed? See, they have given here that this resistance is R and this resistance is R. They are identical. Even this resistance also R. And when it is open, we found that the ammeter is showing a reading of 0.6 amps. Okay, that means this will divide into 2. This current will divide into 2 here, and it becomes 0.3 and 0.3. So here it is 0.3 and here it's going to be 0.3, because same resistance means the current will equally divide. And suppose if the switch this is closed, what happens? The same 0.3 current, okay, will be flowing here. So 0.3 plus 0.3 plus 0.3 is 0.9. So Option A is the correct answer. A wire of resistance 5 ohm is bent in the form of closed circle. See, like this, bent in the form of closed circle. And what is the resistance between the 2 points at the ends of any diameter of the circle? So this point and this is, take this as a diameter. So what is this resistance we need to find? So that means the total resistance is 5 ohm. That means this is 2.5 and this will be 2.5. Okay, because it is, see, this half is going to be 2.5, this half is going to be 2.5, total is 5. So now we need to find the resistance across these points A and B. So now they are connected in parallel. So I need to find this RAB. So 2.5 into 2.5 divided by 2.5 plus 2.5. So if the two resistance of the same value means we need to take R by 2. That is 2.5 divided by 2. What is 2.5 divided by 2? It's going to be 1.25 is the correct answer. Option B is the correct answer. Here, three resistances 1 ohm, 2 ohm, 3 ohm are connected to a 12 volt battery. What is the potential difference across the resistance? R2. So here we need to find. So first of all we need to find the current. What will be the current? I is equal to V divided by RS. You have to take the total resistance for finding out the current. So this is equal to 12 divided by 1 plus 2 plus 3. It's going to be 6. So 12 by 6, it's going to be 2 amps. So total current is going to be 2 amps. And they are asking you to find the potential difference across the R2. That means we have to find this V2. So what is the formula to find V2? V2 is equal to I into R2. What is I2? What is R2? Is 2. So total 4 volt. Option D is the correct answer. Here in the above image, what is the resistance, total resistance of the circuit? See, these two resistances are connected in series. Okay, so it becomes 7 plus 3, it is 10. And this 10 ohm resistor is parallel with another 10 ohm resistor which is over here. Okay, then we have another resistance on the other side, that is 5 ohm and 5 ohm here. So 10 into 10 divided by 10 plus 10 is 5. So here this becomes 5 ohm. Now these three are in series. So 5 plus 5 plus 5 is 15 ohm is the total resistance. Option C is the correct answer, 15 ohm. So in this circuit, what is the effective resistances? We need to find total resistance. The formula for total resistance Rp is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So this will be equal to 1 divided by 1 by 1 plus 1 by 2 plus 1 by 5. Okay. So when we take LCM for this, it's 10, no? So in order to make this 10, here 10 plus 5 plus 1, 10 plus 5 plus 2, it's 17. So 17 divided by 10. So 1 divided by 17 divided by 10. Okay. So that means it is 10 by 17. So what is 10 divided by 17? That will give you the effective resistance. Okay. So The answer will be 10 divided by 17. If we take, it is 0.588. So option C is the correct answer. What is the total current? See how to find the total current here. Total current is equal to V by R. V is 6 and just now we found the total resistance is 10 divided by 17. So into 17 we do. So you cancel this. Threes are and this is fives are. So you can multiply 17 into 3 divided by 5. 21. 3 ones are 3. So it's 51 divided by 5. It is 10.2. Option B is the correct answer. In the given circuit, so these two resistances are connected in parallel, 20 ohm and 20 ohm. So we have to find equivalent resistance means, so I told already that if two resistances of same value, so then we have to divide by 2, R by 2. So it's going to be 10, 10 and 10 in series. So 10 plus 10. So total resistance will be 20 ohm. The correct answer is option C. Here, 48th question. These two, as I already told that here 24 ohm resistors are connected in parallel. So half of this value can be taken. R by 2 will be the total resistance, or 24 into 24 divided by 24 plus 24. So it's going to be 12. So 12 here and 12 here, they are connected in series. So therefore 24 ohm will be the total resistance. But here what they have asked, how much current is passing through 12 ohm resistor? So we know current is equal to V by R. And what is V is 6 and R we just found it, the total resistance is 24. So if we cancel this, we get 1 by 4, which is 0.25. Option C is the correct answer. What is the lowest total resistance that can be secured by the combination of 4 coils of the resistance? So if we want to find the lowest minimum resistance or the lowest resistance, means we need to go for the parallel connection. So when we go for the parallel connection here, so 1 divided by 4 plus 1 divided by 8, okay, plus 1 divided by 12 plus 1 divided by 24, okay. So this will give you the total resistance in parallel. So if you take LCM here 6 plus 1 divided by 6 plus 3 plus 2 plus 1, 12. So 1 by 12 divided by 24. So 24 by 12 is 2. So 2 ohm is the correct answer. Option C is the correct answer. How many 176 ohm resistors are connected in parallel? Okay, so like this we need to find how many 176 ohm resistors can be connected like this. And here the total current is given 5 amps and this is the total voltage. Okay, so here the resistance value is 176. So having given V and I, and V here, I here and R here, so therefore we can write the formula to find the N. We can write I into R divided by V. So here what is the current? 5. 5 into 176 divided by 220. 220. So we can cancel this. And we can find the answer. Four, 44. Okay, so here this and this you can cancel, 44 and this, so 44 into 4 16, remainder 1, 176. So option D is the correct answer. So here 4 ohm and a bulb of 20 ohm, okay, are connected to 6 volt battery. What is the potential difference across the lamp and the resistor? We need to find what is the voltage here and voltage here. So first we need to find out this current I. So I is equal to 6 by 24. Okay, I is equal to V by R. So it's going to be 1 by 4. And what will be the voltage here? V1 is going to be 1 by 4 into V1 is equal to I into R1. V2 is equal to I into R2. Okay, so 1 by 4 into 4 is 1 volt. Okay, V1. What about V2? V2 is going to be 1 by 4 into 20. It's going to be 5 volt. They've asked you to find what is the potential difference across electric lamp and resistor. Potential difference across the lamp is 5 volt and the resistor is 1 volt. It is 1 volt across the resistor. So here the option 5 volt is not given. Actually it should have been given 1 volt comma 5 volt. So option B is the correct answer. So here they have asked what is the power of the lamp. Power of the lamp. So this is the lamp. So here we found out the resistance here is 20 ohm and we found out the voltage here is 5 volt. Okay, 5 volt into the current is 1 by 4. So 5 by 4. Okay, so or else we need to find the power in another way. I square R. I square is 1 by 4 into 1 by 4 R. R value is 20. So 20 by 16. 1 point something. Clear? 1.25 is the correct answer. From the above diagram, calculate the total effective resistances of the circuit. Total effective resistances means 1 by R1 plus 1 by R2 plus 1 by R3. So here it is given 1 by 5 plus 1 by 10 plus 1 by 30. So total effective resistance would be R equivalent is equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So when you take the LCM here, it is 1 divided by 6 plus 3 plus 1 divided by 30. Okay, which is going to be 30 divided by 10, which is 3 ohm is the correct answer. In the above circuit, find the total resistance. So here these two are in series, so therefore 3 plus 2 is 5 ohm. So 5 ohm in parallel with 5 ohm, it's going to be half of the value, 2.5. 2.5 is the correct answer, option B. We have to find the current. So how do we find the current? So it is 2.5, as we have found the total resistance is going to be 2.5. So I is equal to V by R. Okay. So here the voltage is 4 divided by 2.5. What will be 4 divided by 2.5? That is 40 divided by 25. 8 5s are and 5 5s are 8 divided by 5. 1.6 is the correct answer. Option A is the correct answer. Here from the above image, a student made an electric circuit shown here to measure the current through the lamps or the lamps in series or parallel. So you can find that these are the two lamps. See, these two lamps are connected end to end, so it is series connection. Option A is the correct answer. Here we need to find out the total resistance. Always you have to simplify the equivalent, or to find the total resistance we have to go from the closed end, not from the open end. Not from here, we have to go from the closed end. So from here. So these three resistors are connected in series. 20 plus 10 plus 20, it is 50 ohm. So 50 ohm resistor is connected in parallel with this 30 ohm. Okay, that is connected in series with 10 ohm. Okay, so these two are parallel. 30 and 50 ohm are parallel. So 50 into 30 divided by 50 plus 30, which is going to be 1500 divided by 80. Okay, 1500 divided by 80. So if you cancel that, 150 divided by 8 plus 10 plus 10. 10 plus 10 is 20. So these this 150 divided by 8 will be in series with these two, 10 and 10. So therefore 20 plus 150 divided by 8. So here 150 divided by 8 is going to be 1s are 80 and remainder 70 here, and point, if I put point and take 0, 8, yeah, 9s are we can't go, so 8s are we can take 1.8. Okay, so it has to be 10.8. yes, so 8 is this, not divided by 80, it is actually 8, no? So therefore it is 10.8. 10.8 plus 20, it is 38.75. Option B is the correct answer. So in this question, we need to find what is the potential difference across 3 ohm resistor. So here, what is this voltage here? We need to find. So first of all, we need to find the current. So how to find the current? Current is equal to voltage by resistance, total resistance here. You should add all these three resistance. 3 plus 2, 5. 5 plus 1, 6. So it is 2 divided by 6. Total voltage here is 2. Okay. So it is 1 by 3. Okay. So that is going to be the current. What will be the potential difference? Potential difference is this V. V3 ohm is equal to I into 3. So what is I? 1 by 3. 1 by 3 into 3, it's going to be 1. 1 volt is the correct answer. Option A is the correct answer. Here in this, you can find that the resistance, see, it seems to be very complicated. We can't take these three as series because there is a junction here and we can't find the total resistance. So what we have to do is, you better bring this resistance over here. So that means this point A and D is one and the same point. So I can bring it over here. So C and D is like this. And this A point and D point, I bring it over here. So the resistance we get like this. This is going to be point A and a D point. And now here, this B point and a C point is going to be the same. So therefore, if you are bringing this way, so this resistance will go to the top. So like this. So that means these three resistors are connected in parallel. So when three resistors are connected in parallel of the same value, means it's going to be R divided by 3. So R by 3, it's going to be the resistance. Okay, total resistance. Option D is the correct answer. In this presentation, we have discussed various objective type questions on combination of resistance, that is series connection, parallel connection, and we have seen series parallel combination. In the next video, we shall discuss various objective type questions on power and energy and heating effect of electric current. If you like the video, kindly click the like button and share to all your friends. Don't forget to subscribe my channel for the upcoming videos.